So next we are going to see about the types of single phase induction motor. So there are three types: split phase induction motor, capacitor start induction motor, and capacitor start capacitor run induction motors, right? So the first type is split phase induction motor. Right, a split phase induction motor, it is a type of single phase induction motor in which the stator consists of two windings. So one is the main winding and the other one is the starting winding. So in this case, both these windings are displaced by 90 degree from main winding. So we can say they are 90 degree out of phase with each other. Right? So here the starting winding operates only during the starting period of the rotor. So after the motor is started, it is disconnected from the circuit. Right? So this is the circuit diagram of a single phase induction or split phase induction motor. So as you can see, we are having two windings. One is the main winding and starting winding at 90 degree to each other. And in addition to that, we also have a centrifugal switch. So now this purpose of the centrifugal switch is, so initially the starting winding will be connected with the main winding. So as the motor is started, it starts to gain speed, right? So once it reaches around 60 to 70% of its rated speed, it creates enough centrifugal force to open this switch. So this switch operates or opens due to the centrifugal force of the rotor, right? So once the switch is open, the starting winding gets disconnected from the main winding, right? So that is the purpose of centrifugal switch, to disconnect the starting winding from the main winding after the motor reaches a particular speed, right? So here the starting as well as the main winding are designed to have different resistance, right? So the starting winding has high resistance and low reactance, whereas the main winding has low resistance and high reactance. So due to this, the current flowing in the two windings have a reasonable phase difference of around 25 to 30 degrees. Right. So next we are going to see about capacitor start induction motor. Right. So here, this type of single phase induction motor, we have a capacitor connected in series with the starting winding. So this capacitor is called as the starting capacitor. So this value of this capacitor is chosen such that the starting current leads the main current by about 80 degrees. Right? So this capacitor is used here to create the phase difference. So instead of differing a resistance in case of split type induction motor, here we are using a capacitor to create the phase difference. So the construction is similar. Additionally, we have a capacitor in series with the starting winding. Okay. So once the motor attains the 75% of rated speed, the centrifugal switch is open. Right? So what happens? The main starting winding gets disconnected from the main winding. Right? So then the motor operates a single phase induction motor and continues to accelerate till it reaches its normal speed. So as I said, the capacitor in series creates the phase shift between the two windings. So this phase shift will enable the motor to self-start. So the final type is capacitor start, capacitor run induction motor. Right? So this construction is almost similar to the capacitor start type induction motor, except that the starting winding is not disconnected from the motor circuit. So here the starting winding is continuously present along with the main winding when the motor is running. Right? So therefore, in case of capacitor start, capacitor run induction motor, both windings, that is starting winding and main winding, remain connected to the supply during starting as well as during the running period. Right? So here is, as you see the construction, so the second capacitor is in parallel with the first capacitor, right? Right. So here the values are chosen such that the capacitor C1 has a small capacitance value, right? So hence it is permanently connected in series with the starting winding. and the value of capacitor C2 is very high, and it is connected in parallel with capacitor C1, and this capacitor remains in the circuit only during the starting period, right? So here the starting capacitor C2 is isolated from the circuit by the centrifugal switch. So once the motor reaches its rated speed, the capacitor C2 gets disconnected. So in the previous case, both the starting winding as well as the capacitor gets disconnected. Here only the capacitor C2 gets disconnected, whereas the starting winding along with the low value capacitor is in continuous connect with the motor, right? So next video we'll see about the applications of these types of motors.